Hello, you are listening to Pankaj Rai, and in this video we will be discussing the numericals of the chapter Solutions and Colligative Properties. Let us begin with the concentration. Now there are 5 ways to discuss the concentration of a solution, and we will be discussing all of them one by one, starting with first one, which is percentage by mass. It is weight over weight, okay, and it is given by mass of solute which is dissolved in the solution divided by mass of the complete solution times 100. Okay, so it is mass upon mass, both has to be in grams or both has to be in kg, so it will be unitless and it will be only a numeric value in percentage. You can also write it as mass of solution can be broken into two masses of solute and solvent. So this can be written as mass of solute divided by mass of solute, excuse me for that, that is mass of solute plus mass of solvent, because mass of solute plus mass of solvent will be equal to mass of solution times 100, and it would be in percentage. Okay, so this is very simple. Now we'll move ahead with the next one. Now the next one is percentage by volume. It is volume over volume. Okay, it is given by volume of solute, sorry, it is volume of solute divided by volume of solution times 100, and obviously both the volumes has to be in the same unit, and it will be a numeric value in percentage. You have to remember that in this case the volume of solution cannot be broken down into two parts like volume of solute plus volume of solvent. Okay, because the total volume may or may not be equal to the sum of the individual volumes, because the solute might take the free spaces in the liquid. Okay, so the volume may not be same, so you can't use a formula which is similar to this. Okay, so you have to use this formula only. But the most important part here is that both the uh, volume of solution has to be in the same units, and that's where the major mistakes come. So I'm giving you all the conversions. Okay, now remember that 1 meter, okay, is actually 10 decimeters. All right, so I can say that 1 meter cube is equal to 10 raised to 3 decimeter cube. Okay, next one, you should know that 1 meter is 100 centimeter, so 1 meter cube can be written as 10 raised to 6 centimeter cube. All right, and what about the conversion between the decimeter and centimeter? You can see both are 1 meter cube, so you can equate them. What you will get is 10 raised to 3 decimeter cube is same as 10 raised to 6 centimeter cube, so you can write it as that dividing by 10 raised to 3, so you'll get something like 1 decimeter cube is actually equal to 10 raised to 3 centimeter cube. You can also say that 1 centimeter cube is equal to 10 raised to minus 3 decimeter cube. You should remember all these conversions, and you can convert from meter cube to centimeter cube to decimeter cube. Also, there is one more thing which you should remember, is that conversion from liter and milliliter to decimeter cube and centimeter cube. You should remember one thing, that 1 liter is actually nothing but 1 decimeter cube, okay, and 1 milliliter is nothing but 1 centimeter cube. So a liter is similar to decimeter cube, and a milliliter is similar to centimeter cube, okay. So in this way they might give you the volume in any unit, so you will be able to convert them, okay. So you have to remember that. So this is a division, and let's say we move ahead to our third topic, which is mole fraction. Now, mole fraction is very simple. So let me say that let's say we are having N1 as number of moles of solvent, and let's say N2 we are having as number of moles of solute, okay. So let's say that x1 is mole fraction of solvent, and let's say x2 is mole fraction of solute. So mole fraction of solvent, which is x1, is given as number of moles of solvent, which is N1, upon total number of moles, which is N1 plus N2. And similarly, the mole fraction of solute, that is solute, mole fraction of solute x2, will be given as number of moles in solute, which is N2, upon total number of moles in solution, which is N1 plus N2. It is very simple, okay. But the most important part is that how to find the number of moles. First of all, let me tell you about the unit of this. Now this is number of moles which will be in moles, number of moles which will be in moles, so both will get cancelled because numerator and denominator are of the same unit, so this will be unitless, you have to remember that, okay. But the most important part is how to find the number of moles, okay. So the formula for number of moles is, we have number of moles is equal to the mass of the substance divided by molar mass or molecular mass of the element, okay. Now this mass has to be in let's say gram, and this molar mass will be in like gram per mole, so eventually you will get number of moles in the unit of mole, okay. Now it might also happen that you have been given mass in kg, so you convert it to gram, and you might have been given molar mass in kg per mole, so convert it in gram per mole, and you should be able to move ahead with this formula, okay. Now there is one more thing to find out the molar mass, because it might be possible that they may just give you a compound and they may ask you to find out the molar mass by yourself. So you should remember the molecular weights of few of the elements, okay. That is very very important. So let me give you the molecular weight of some elements, like let's say we have hydrogen, it's 1. Then we have carbon, it is 12. Nitrogen is 14. Oxygen is 16. Sodium is 23. Then we have sulfur, it is 32. After sulfur we are having chlorine, it is 35.5. And after chlorine we are having calcium, which is 40. So these are the most of the elements which you will require to find out the molecular mass, okay. For example, if I take an example, let's say we find out molar mass of H2SO4. So how do we do that? Now H2SO4 will be like we are having two hydrogens plus we are having one sulfur plus we are having four oxygen. So what you have to do is 2 into molecular weight of hydrogen, which is 1, plus 1 sulfur, so 1 into 32, plus we are having 4 oxygen, so it will be like plus let me just write it again. So we will have something like uh, 2 into 1 plus 1 into 32 plus 4 into 16, so that will be like 2 plus 32. So 2 plus 32 plus we are having here 16 times 4 is 64. So 2 plus 32 is 34 and 34 is 64 will be 98. So molar mass or molecular weight of H2SO4 will be 98 and it will be in gram per mole. So this is the way you can find out the molecular weight of or molar mass of any compound. Okay, so in this way you can find the molecular mass, and mass might be given to you of the substance, take it in gram, so you'll get the number of moles, and in this way you can find the mole fraction. Okay, let's move ahead with the fourth one. Okay, I just got rid of that formula for finding out the molecular weights of the compound. Okay, so this was the third one which we just did, which is the mole fraction. Now let us move ahead with the fourth one, and the fourth one is molarity. Now what is molarity? It is denoted by capital letter M first of all, and molarity is defined as number of moles of solute divided by volume of solution, volume of solution. Okay, and this volume of solution has to be in decimeter cube compulsorily. So number of moles of solute, we just discussed how to find the number of moles of any solute. You can do that, so that would be in moles, and the volume is in decimeter cube. If they are giving you volume in any other unit, you can convert it by using these conversions, so you will get the volume in decimeter cube. So eventually the unit of molarity is mole per dm cube. So it is very simple. Now we are moving ahead with the last one, which is molality. Molality, it is denoted by small letter m, and molality is defined as number of moles of solute divided by, we have here mass of solvent only, mass of solvent only, and that has to be in kg. Okay, so the number of moles you can find out, and mass of solvent, if it is given in any other unit, you just get converted to kg. So molality, which is number of moles upon mass of solute, mass of solvent in kg, will have unit of mole per kg. Okay, so these are the 5 ways to represent concentration of a solution, and by using whatever we have just discussed, you can solve any numericals based on concentration. Thank you very much.